Hello everyone, you're welcome to this tutorial, which is a continuation of the calculus series, and we are going to be diving into application of differential calculus. Once again, my name is Peter OYEWALE from Learnwithuncletee, and I know you're going to gain a lot from this tutorial. So without wasting much time, the topic is tangent and normal to a curve. Tangent and normal to a curve. Now, firstly, one of the first things that we need to understand are the keywords used here, which is tangent, normal, and also a curve. Now, if I'm to explain a tangent, we have to represent a circular figure first in terms of, let's use a circle. So let me assume that we have a an innocent circle here. Okay. Now, if we are to draw a tangent to this circle, a tangent is a line that is going to touch the surface of the circumference. So, for example, let me start the tangent from here. So, it's going to touch the surface of the circumference. So, if I stop it there, it means that this is a tangent to this particular circle, touching the circumference. Now, so that's the explanation of a tangent. When you hear the word normal in mathematics, let's assume that we have a straight line. You know, a straight line is the shortest distance between 2 points. So let me say that this is a point where we have Peter, and this is another point where we have Paul. They are both standing on these exact points. I'm using a cardinal point, the Cartesian coordinates now to represent that. That's your north, west, east, and south. The shortest distance between Peter and Paul is always going to be a straight line. So if you are trying to connect Peter and Paul, if you start from this point and you want to connect the shortest distance between them, it's going to be a straight line. So that's the definition of straight line. So where we are going to is normal. Now, if you are to divide this particular straight line, which is the shortest distance between Peter and Paul, into two equal parts, we have to use the construction method in which we call bisection, perpendicular bisector. So if you place your compass at any convenient radius, the needle point on point Peter, and you describe an arc at the numerator, sorry, I said numerator, that is at the top level, and you also describe an arc at the bottom level. You repeat the same process for Paul. You cut that arc up, and you also cut it down. The point of intersection uh between those two, if you connect them together, you get a perpendicular bisector. So a perpendicular bisector in a way is also referred to as a normal. So you discover that the distance between here, that is, if we call this the midpoint, which is our M, the distance between Peter and the midpoint will be equivalent to the distance between the midpoint and Paul. These two distances will be the same. So the addition will now give you the total distance, which is the length of the straight line. So you discover that if this is your, I don't want to go more into coordinate geometry now. So let me just restrict myself a little. Okay. This angle is going to be a 90-degree angle. That is certain. Then one other thing you need to know is that just know that because we are dealing with application of differential calculus here, normal goes with the word perpendicular. Why tangent goes with the word parallel. So know that tangent goes with the word parallel, normal goes with the word perpendicular. You are going to get the reason why we are representing them using those words now. So one thing you now also need to know is that the general equation of a straight line, because here we are going to be trying to find the equation of tangent and normal to a curve, and a tangent and a normal, they are straight lines. So we need to know the general equation of a straight line, which is y is equivalent to mx plus c. Now, before I go to the conditions, this m here represents your gradient, while your c represents your intercept. Okay, now gradient is basically a synonym of derivative, which sometimes you can also refer to as your slope. So gradient is the same thing as derivative, is the same thing as slope, while your c represents your intercept. So y is equal to mx plus c is the general form of a straight line. So now we know that the formula for finding gradient, which is your slope, is defined by y2 minus y1. Everything is being divided by x2 minus x1. So y2 minus y1 is your change in y, which is delta y. X2 minus x1 is your change in x, which is delta x. We are going to get to approximation because also in differential calculus, delta y over delta x in differential calculus is approximately equivalent to the y dx. So that's why we can also regard to as gradient as our derivative, which is our the y dx, using application of approximation. Okay, now aside that, when two straight lines are parallel to each other, what do we mean by being parallel to each other? Let's assume that we have a straight line, then we also have, so that's the first straight line. Then let's say we have another straight line, and these two straight lines are parallel to each other. The condition, if this straight line has a gradient of m1 and this second straight line has a gradient of m2, when they are parallel to each other, they are going to have equal gradients. Our m1 will be equivalent to our m2. Now, when two straight lines are perpendicular to each other, let's say that we have the first straight line. So let's say we have the first straight line here with a gradient of m1. Then we have the second straight line as a perpendicular bisector with a gradient of m2. The condition is that the product of the gradient to be equivalent to -1. So I don't want to go deep into proving of most of these formulas because when we start series on straight line coordinate geometry, you're going to understand these things better. But if you are just studying a calculus course in respect to application of differential calculus, what you're going to need basically are the formulas and the necessary conditions. Now, one thing you need to know is that I've told you already, when you are dealing with parallel lines, tangent goes with parallel lines. So it means that if we are finding the equation of tangent, we use the condition for parallel lines, which is m1 is equal to m2. So if we are looking for equation of normal, we use the condition for what? Perpendicular lines. So which is m1, m2 is equivalent to -1. So this second one is when you're finding your equation of normal. m1, m2 equals -1. For equation of tangent, your m1 is going to be equivalent to your m2. Now, one thing you also need to note, aside this general formula, we can, in coordinate geometry, or let's say in straight line as a topic, we have particular equations in which, or let me say, we have particular formulas in which you can use to find the equation of a straight line when given a point, when given 2 points, and a gradient, and the rest. So, if we are given a point and a gradient, the formula in which we use to find the equation of a straight line is y minus y1 is equivalent to m into x minus x1. So basically, this is a very important formula that you need to know. Another very important thing that you need to know is this condition for normal. M1, M2 is equal to minus 1. Another thing is that is very important for you to know is that M1 is equal to M2 condition for tangent. Then you also need to know the general equation of a straight line, which is y is equal to mx plus c, to sometimes identify your gradients. But most times you find your gradient using your derivative and it's going to be instantaneous at that particular point, at that particular instant. So you're going to get what we're actually saying. Now, let's take an example. Okay, so now if we consider this example, find the equation of the tangent and the normal to the curve. I take the question again. Find the equation of the tangent and normal to the curve y is equivalent to 2x raised to the power of 3 minus x raised to the power of 2 plus 3x plus 1 at the point x is equal to 1. So we have to find the equation of tangent and, okay, let me write here. We have to find the equation of tangent and normal to this curve at the point x is equals to 1. So firstly, you know that x is your independent variable because that's the variable in which you are being given. The value of y is going to depend on x, which will make y the dependent variable. So let's find our dependent variable first, which is our value of y. When our x is 1, our y will give us, anywhere we see x in this equation, we're going to substitute 1. So we are going to have 2 multiplied by 1 raised to the power of 3 minus 1 raised to the power of 2 plus 3 multiplied by 1 plus 1. So this is going to give us y is equal to 1 raised to the power of 3 is 1 times 2. That will give us 2 minus 1 raised to the power of 2 is 1 plus 3 times 1. That will give us 3 plus 1. So minus 1 plus 1 will give us 0. 2 plus 3 will give us 5. So our y is equivalent to 5. Now, since our y is equivalent to 5, it means that the point that has been given in the question now will be the point x, y. And our x coordinate here is 1. Our y coordinate here is 5. So this will therefore serve as our x1 and our y1. Now let's go straight into the question now. One other thing that we need to find here is that since we have been given y as a function of x, we can find our dy dx, which is our gradient. So dy dx will give us, if we differentiate 2x with power 3, you're going to get 6x squared. If we differentiate minus x squared, you get minus 2x. If we differentiate 3x, you're going to get plus 3. If you differentiate 1, you're going to get 0. So at x equals 1, our gradient, which is our same thing as our dy dx, will give us, anywhere we see x, will substitute 1, 6 into 1 raised to the power of 2 minus 2 raised to the power of 1 plus 3. So 6 minus 2, that will give us 4 plus 3, which will give us the gradient as 7. So for the first one, which is for the equation of tangent, don't forget the condition is m1 will be equivalent to m2. So it means that here our m2 is automatically going to give us 7 because m1 we have gotten it to be 7. That's the initial gradient. So we just basically use the formula, which is y. We know a point and we know a gradient. So that's y minus y1 will be equivalent to m2 into x minus x1. So this will give us y minus our y1, that's 5, is equivalent to our m2, which is 7, into x minus our x1, which is what? 1. So this gives us y minus 5 will give us 7 times x, which is 7x. 7 times 1, that will give us 7. So we are now left with y minus 7x minus 5 plus 7 is equivalent to 0. So we now have y minus 7x. Minus 5 plus 7 will give us plus 2 is equivalent to 0. So it means that the equation of tangent to the curve 2x raised to the power 3 minus x squared plus 3x plus 1 is going to be y minus 7x plus 2 is equal to 0. It's practically and basically simple. So what you need to just know is understand the condition that guides equation of tangent, understand the condition that guides equation of normal. So let's do the equation of normal now. You discover that it's basically very simple. Now, if I put down, let me say normal. So do you remember what's the condition for normal to the curve I gave you earlier? The product of their gradients will be equivalent to minus 1. So we have m1 multiplied by m2 is equal to minus 1. So we need to find our m2 here. So since our m1, we have gotten our m1 to be, that's 7. So we are going to have 7 multiplied by m2 to give us minus 1. So if you make m2 the serial formula here, you will get your m2 to be equivalent to minus 1 divided by 7. So using the same equation again, you have y minus y1 is equal to m2 into x minus x1. The only thing that is going to change here is your gradient. That's what changes in just these two solutions. So we are going to have y minus our y1 is 5 is equal to our gradient minus 1 over 7 multiplied by x minus our x1, which is 1. So here we have a fraction here. We can just multiply through by 7 to cancel out the 7. So we are going to have 7 times y, that's 7y, minus 7 times 5, 35, is equal to, if you multiply this fraction by 7, we need to cancel out the 7. So we'll be left with minus 1 into x minus 1. So this is 7y minus 35 is equal to minus 1 times x, that's minus x. Minus 1 times minus 1, that will give us plus 1. So we'll now be left with 7y plus x minus 36 will now be equivalent to 0. And 7y plus x minus 36 will be equivalent to 0 is going to be the equation of normal to that curve. So again, as a remark, understand the conditions. For equation of tangent, your m1 will be equal to your m2. For equation of normal, the product of your gradient will be equivalent to minus 1. The general equation of a straight line when you know a gradient and a point is y minus y1 is equal to m into x minus x1. And to find your gradient when you are given any initial value problem is that you differentiate the function and you impute the value of x at that particular point so that you'll be able to find the gradient at that point. So for this tutorial, this is where we are going to bring this tutorial to an end. Basically, you can apply this to any question that you have on the tangents and normal to a curve. If you have any question, you can drop them in the comment section. If you have not subscribed to the YouTube channel, do that. You're going to get a load much of value coming. We have loads of tutorials that we are going to unveil in the meantime. So without further ado, see you in the next tutorial. Thank you.